Hi folks, I'm Olga and welcome to the complementary video on how to read Z and T tables. In episode 5 I tried to explain what is normal distribution, also called Z distribution, and what's T distribution. You remember that first of all, area under the curve is always 100%, whether it's Z or T distribution. Secondly, roughly said, T distribution is a clone of Z distribution that accounts for a sample size. And finally, horizontal axis has standard units or number of standard deviation from the mean as its units. So to sum, from the graph you see on your screen, you can notice that if we know the distribution or type of distribution, mean and standard deviation or number of observation in the sample, and if we have some observation, one particular data point, we can place this observation on the standardized graph and we can learn about the area under the curve to the left and to the right from this standardized point. So in a way, we can connect the number of standard deviation or number of standard units from the mean to the area under the curve. Let's look closer at the normal table. Usually such statistical tables are at the beginning and at the end of your textbook on statistics, and you're supposed to use them. Anyway, what we'll look at now is really important for your intuitive understanding, for your further understanding of many statistical procedures, and even for your understanding of output of some statistical package that you use. So this is normal table, and I suggest you to look at an example now. So the question is, what's the area to the right from point Z when Z equals to 1? So Z equals 1 means that our observation is one standard deviation above the mean. In our table we will find A, capital A, or area that corresponds to Z equals 1. If you remember episode 5, where we looked at the properties of the normal distribution, this picture would be helpful for you. So normal distribution is symmetric around the mean, meaning that 50% of observations are to the left and 50% are to the right from Z equals 0, which is our mean. Graphically, the mean is where the red line, but if Z equals 1, we are one standard deviation or one standard unit above the mean. So to find the corresponding area, we need to add one more section, so to say. So area to the right from Z equals 1, or our violet line, area to the right from our violet line is 50% plus 33.13%. And that is exactly what our table gives us. Here is another example with details on Z-value calculation and finding corresponding area. I skip the explanation of it for the sake of time, but you can stop the video and learn the example closer. Okay, so now normal table can look a bit differently, but again, if you remember about 50% area to the right from 0, you shouldn't face any problem. It shouldn't be a problem for you to get again 84.13%. Again, example for your self-studying is given, but we don't stop here and move to the T distribution and T table. T-table will be somewhat different because we need to account for the sample size, but there is no really sample size in the table. There is degrees of freedom. Degrees of freedom can be calculated in many different ways, and the way to calculate degrees of freedom depends on the statistical procedure or method you are using. But in our case, we have the simple version and very simple formula suggesting that degrees of freedom for T distribution in our case are number of observations or our sample size minus 1. So let's look at the T-table now, once you know what are degrees of freedom, are. And every row in T-table starts with degrees of freedom. So you need to calculate degrees of freedom firstly, then you will find a row to look at. Then in that row you look at your t-value. For example, we calculated some t-value, and this t-value is equal to 2.92. Finally, you see to what column your t-value belongs. In our case, the column heading is 0.05. It means that the area to the left from our t-value, which is equal to 2.92, is 5%. Alternatively, you can have information about degrees of freedom and area, and from that information you then can find your t-value. And the second case is very typical for hypothesis testing, so we will talk more about it in the episodes on hypothesis testing. As for now, I stop here, and I hope you know how to use statistical tables now. Good luck in your studying statistics, and see you in the next episodes.